This next problem borrows from all of the ideas of the current module, but in truth, it is a problem found in the next module. Before we encounter this type of problem in its full glory, we will first work it through in the context of this current module.
Okay, so here's the scenario we're looking at. All right, so here's the scenario we're looking at now. The average adult score on a psychometric test for 100 adults. So the score here is not, the score is not what the 100 adults got. It's the average of the 100 adult scores tests altogether. The average is 50, and the standard deviation is 1.5. And it turns out the sample means are normally distributed. All right. So, and this is the type of problem that we are going to start leaning more towards in the analyses we're going to be working on here in a moment, or for the rest of going forward in the term. So, what is the probability of randomly getting a sample with 100 adults with a sample mean of 55 or higher? Okay. Now again, this is higher, so we wouldn't want equals. So at first pass, you'd think, oh, this is a norm dist function. So I would do something like this. So norm dist parenthesis, and then we say 55. We give the mean. So we know that the mean is 100. Oh, no, I'm sorry, the mean is 50. So we know the mean is 50. The standard deviation is 1.5. Again, we know to always say true. What's wrong with this? What's wrong with this as I've written this function? 1 minus. This, we're asking for the area greater than or higher. So norm dist and norm s dist always give the area to the left. Yeah. If I'm making a quick sketch of this scenario here, let me do again. This is just gonna be sort of a quick and dirty sketch of the scenario. We've got our normal distribution, and it's centered at 50. That's 50. And we've got the value 55, but we want the value 55 or above. So since we're looking for this region here above, we need to do the 1 minus. Exactly right. So in here, everything's fine, but I would need to put in here the 1 minus. Okay. If I do this, then I actually get the probability. Now it turns out to be quite small. It's actually 0.0004, or we would often write that as 0.04%, or in other words, it's less than half of 0.1%. Okay. And here's the interesting part. If I ask for an even higher value, let's take it even higher. It turns out that as this average score goes higher, if the mean was 57 or higher, so if I change the 55 to a 57, the answer comes out to be, it looks like this. It's 1.53e minus 0.6. Well, remember, this notation here means that we have to move the decimal place over 6 places. So this is a really, really, really small value. The point being, as the means get higher and higher, at some point they start to become very unlikely to have occurred just by chance. All right, that's the takeaway message for this type of a scenario. So let's officially. So that was sort of the precursor of where we're going. The idea is this. What I did is I want to emphasize that 55 is not a score. Notice 55 is actually a mean. It's a sample mean. And that's the idea of what we're going to be talking about in the next module. And the focus is on the sampling mean.